Good day, everyone. My name is Ace de Malanta, and welcome to our presentation of JEDTINE Fuels Analytics System. With me are Jedrick Mariano and Justin Rivera, and this is an overview of our project. Next slide, please. First, let's start at section 1, which is our assigned topic. Our assigned topic is a fuel analytics system, and after careful studies, we have concluded that our project is a feasible undertaking. We decided to generate our data through AI tools, and we proposed early on the following KPIs, which are total fuel sales per branch per month, revenue breakdown by fuel type, top and bottom performing branches, year-over-year sales growth, and average transaction value per customer. Next slide, please. For section 2, we have the business description. For JEDTINE Fuels Corporation, it is a Philippine-based petroleum retail company established in 2005 with over 20 years of operations in fuel distribution industry. The company operates 10 fuel stations strategically located across the Philippines, covering key areas in Luzon, Visayas, and Mindanao. JEDTINE Fuels employs 5,000 personnel across its 10 branches, consisting of station managers, pump attendants, cashiers, and administrative staff. The company serves thousands of individual motorists, delivery companies, and fleet operators annually. Next slide, please. Now we have operations and strategic concerns. We have the corporate footprint, the sales and inventory monitoring, and compliance efficiency. Next slide, please. For the products and services we offer, we have gasoline regular, premium gasoline, super premium gasoline, diesel, and premium diesel. And next slide. For the business rules, we set out to write quite a number of business rules to keep our data consistent. For the first one, we have each branch is identified by a branch ID and located in a specific region. A branch can have multiple employees assigned to it. Each employee belongs to only one branch at a time, and a customer can make multiple fuel transactions across different branches. Each fuel transaction is processed by exactly one employee. A transaction records the fuel type, quantity dispensed, unit price, and total amount. Each transaction is associated with one payment method, example, cash card, e-wallet, or fleet card, and fuel prices are updated weekly based on price bulletins and vary per fuel type. Each branch maintains its own fuel inventory per fuel type. Fuel inventory is updated every time a delivery is received or a transaction is completed. A fuel delivery is made by one supplier and received by one branch only. A supplier can deliver fuel to multiple branches. Each shift covers one employee for a specific time period at one branch. The transaction is linked to one shift record. Each branch has one active manager assigned at any given time. A customer loyalty account is linked to one customer and earns points per transaction. And a branch can sell multiple fuel types. Next slide, please. Now, as we can see here, this is our ERD for our operational database. We have shift connects to transactions, to payment, to inventory, and so on and so forth. Next slide, please. And this is our database normalization process. First, we have our unnormalized sales slip. Raw slips captured at the point of sale allow repeating lines per transaction for duplicates. This leads to severe data redundancy and database insertion anomalies. For our first normal form, we eliminated those repeating groups by flattening records. We structured atomicity utilizing a composite primary key, which is transaction ID and fuel type ID. And for our second normal form, we remove partial dependencies attributes depending solely on part of the composite key, like fuel name and pricing, and they are extracted into fuel type. For our 3 and F, we have eradicated those transitive dependencies, and customer, employee, and branch details, they are segmented into distinct lookup tables, therefore achieving a completely normalized, clean 3 and F database schema. Next slide, please. For our section 3, which is our relational model, our database implementation actually, we have made actually these following tables, which is fuel type, supplier, branch, employee, customer, shift, transaction, payment, inventory, delivery, and loyalty account for our operational database, which is separate from our data warehouse. And now we move on to section 4 for our data analysis and business intelligence. And I hand it over to my groupmates.
So for section 4, we analyzed JEDTINE fuels using SQL on the operational database. So we answered management questions about branches, employees, fuel, customers, payments, and trends. And I'll walk you through those findings. So let's proceed to the next slide. Okay, so for management questions and findings, so we answered 20 management questions across 5 business areas, and we analyzed over 6,000 transactions with a total revenue of 11.6 million. And yeah, so next slide, please. Okay, so for the branch performance, we discovered the highest branch revenue is Davao City at 1,254,425.25 pesos. And the fewest transaction is at Manila with 554 transactions. And the top region by revenue is the NCR, and in with 2,236,690.85 pesos, and the highest average transaction value is at Davao City at 2,023.27 pesos. And next slide, please. And here we can see here is the employee performance. And for employees, Christy Young handled the most transactions with 12. And Sarah Harris generated the most revenue at 27,104.15 pesos. And in San Fernando, it has the highest average transactions in our employee on valuing 3.45. And we also discovered that the active employees is at 4,507, and 493 are inactive employees. And this is mostly attendants and cashiers. And next slide, please. So here for fuel and fuel type and product mix. So the most frequent purchased is the gasoline regular at 2,371 times that it is purchased. And for the top revenue generating fuel is also the gasoline regular, the value of 4,495,190.44 pesos. And the total volume of gasoline and diesel, and I mean the gasoline is valued at 145,235,235.99 liters, while the diesel is 50,424.44 liters. Now, moving on to the next slide, please. Now, this is the customer behavior. So for customers, Jennifer Bennett is the top spender at 24,256 pesos. And corporate customers spend slightly more per transaction than individuals. So 1,964 pesos over 1,929 pesos. And most loyalty members are bronze tier with 461 accounts than silver and gold. And moving on to the next slide. So this is the time-based trends. And for trends, on May 2026 had the highest activity with 1,095 transactions, and the total revenue of 2026 is 11.62 million pesos, and Tuesday is the strongest sales day at in revenue. And moving on to the next slide. Okay, so this is the payment and supply chain. So for payments and supply, cash is the most used payment method with 2,000 plus uses, and National Oil Partners is our top supplier, delivering 250K liters of fuel, and that covers the operational SQL analysis. And yeah, I will hand this off to Mr. Mariano for the next slide. Thank you.
Okay, so thank you for that. So now let's start with our SQL. So for our SQL reports, we use three main features: the joins, group by, and aggregates covered most of our queries. Ranking functions like rank and then shrunk help us find our top performers. And data analysis let us study trends over time. So next slide, we created 20 KPIs in total. The most important ones, like the total revenue and monthly revenue, are stored in our warehouse since they are used often. And others, like employee productivity, are calculated by only when needed. So each KPI has a clear formula and purpose, like average transaction value showing typical spend per visit. So next slide. Our old database had problems. So reports needed too many joins were slow since nothing was pre-summarized and historical analysis was hard with no date dimension. So with this, data was also scattered across departments and rankings had to be recalculated every time. This is why we needed data warehouse. So next slide. Um, Now we move on to data warehouse planning. So we planned our warehouse around fuel sales transactions with one row per transactions. Our key measures are liters dispensed, total amount, unit price, and amount paid. We built six dimension tables: date, branch, employee, customer, fuel type, and payment method, each with important attributes pulled from the source data. So next slide. It is our star schema. So uh, the fact sales table sits in the center, holding our measures connected to six dimensions table around it. This shape makes the query much faster and simpler than joining many operational tables. Moving on to the next slide, we have the ETL process. So to build the warehouse, we run an ETL process. We extracted 6,000 transactions from six tables, cleaned the data by removing duplicates and invalid rows, then loaded the dimensions first, followed by the fact table. In the end, all 6,000 rows were loaded cleanly. Next slide, we have the OLAP queries. So with the warehouse ready, we run the OLAP analysis using six operations: roll up, drill down, slice, dice, ranking, and trend analysis to explore the data from different angles. Next slide, we have the OLAP findings. So here's what we found. NCR is our top revenue region. About 76 of revenues comes from gasoline. Davao City is our top branch, and Brenda Miller is our top employee. And as of May 2026, it is our peak month, and Tuesday and Sunday is our busiest days. So next slide, we have the dashboard. So this dashboard brings it all together, showing revenue trends, branch, performance, fuel category split, payment methods, customer types, and revenue by region, all in one view. So finally, using linear regression on our monthly revenue, we forecast August 2026 revenue at about 2.1 million pesos, growing by roughly 48,500 pesos each month. This gives us the business a solid starting point for planning ahead. So that's basically it for our presentation. Thank you.